All right. Hello. Welcome back to AP Calculus. This is lesson 2. I have divided this section into 2A and 2B, and then I'm just going to cover both 2A and 2B in this video, but this is evaluating limits analytically. So, last section we defined what a limit is and how to identify them when we have a graph of a function. Graphs are nice because we can actually see what's going on at locations we're looking at, but what do we do when we can't see the graph and all we have is an equation? That's what we're going to cover today. So our learning targets for today are we're going to evaluate a limit using the properties of limits, develop and use a strategy for finding limits, evaluate a limit using the direct substitution method, and evaluate a limit using the simplify/reduction method. This is going to be part of 2A. Okay, so let us go to the rules. Okay, so for this lesson, you have to know these rules. Now, this is the limit of b is equal to b. So, example, if I have the limit of 7 as x approaches c, which is just any number, it's going to equal 7. As long as there's no, like, x value in there, the limit of whatever this number is going to equal this number right here. Okay, suppose that the limit f of x as x approaches c equals L, then the limit of b times f of x is equal to b times L. So basically, we can multiply any limit function by a constant. And as you know, limit function was a term we defined last lesson. So if you missed last lesson, I'll link it in the description below. Okay, the next one is the limit of x as x approaches c is equal to c. Example, the limit of x as x approaches 5 is equal to 5. And the same principle for this one applies down here too. So the limit of x squared as x approaches c is equal to c squared. So example, the limit of x squared as x approaches 6 is equal to 6 squared. Basically, we're just going to plug in the value c into our equation. Okay, time for the next part of this lesson is the direct substitution method. So, to find limits for a function, first try to evaluate the argument in the expression. So, just plug in the value. If the resulting value is a real number, then the value is the limit, which is our answer. So, if we have the limit of f of x as x approaches 2 is equal to x squared plus 3x, we're gonna plug in the 2 into this guy right there. So, 2 squared plus 3 times 2 is equal to 4 plus 6, and that's a bad erase or equal sign, is equal to 10. So that would be our answer for this guy. All right. So here's some more examples of this. So the limit of f of x as x approaches -1 is equal to 3x to the 5th minus 2x squared plus 7x plus 4. This is a bigger problem than the last one we did, but it's still pretty simple. So we're going to do 3, not a very good 3 times -1 to the 5th minus 2 times -1 squared plus 7 times -1 plus 4. Okay. -1 to the 5th power is just -1, times 3 is -3. -1 squared is +1, but times this -2 makes it -2. So -3 minus 2. 7 times -1 is -7, so -7 plus +4. This is going to be -8. That is our answer. Boom. That's how you would do that guy. Okay. The next one. This is a rule, like the last page. This was a rule from that I showed earlier that you have to know. So the limit of 5 as x approaches 2, since there's no x value in here to plug in 2 into, the limit of 5 is just going to be 5. Okay. And then for our last example on this page, we have the limit of f of x as x approaches pi is equal to x cosine x. So, like we did for the top one, we're going to plug in pi into this equation. So, pi times cosine pi. That's not a very good bracket. Okay. Still a little too big. There we go. Okay. Cosine of pi is -1, so we have pi... Not a good pi. Sorry, I'm writing on mouse, so it's not exactly the greatest. Times -1, which is just negative pi. There. So that's how you would do that guy. So, time for... Now with this out of the way, it's time for our next part of this. So, it's time for the simplify/reduction method, or just the factor, simplify, substitute, and these are the steps for them. So we're going to evaluate the argument by first plugging the value into the expression. If you get a real number, like we did for on the last page, we got like real numbers or values, so we were done with that. But if the direct substitution produces a 0 over 0, which is indeterminate form, we need to evaluate further. No, 0 over 0 does not mean that the limit is undefined. It just means that our problem is incomplete and unfinished. So we need to just evaluate further to try to get a real equation. So how we do that is we try to find common factors in order to reduce the expression, just working to reduce. And then using the reduced expression, we re-evaluate the limit or simplify the equation, and then confirm that the resulting value is now a real number, therefore it is the limit, our answer. Alright, so if you want to like take a second, pause the video, and write all this down if you really want it, go for it, but I'm going to move on to some examples of this now. Okay, so our first example here is the limit of f of x as x approaches -2 is equal to x squared plus 5x plus 6 is over x plus 2. Alright. Alright, so we're going to start by plugging in -2 into this equation. So I'm going to do this up here real quick. -2 squared plus 5, -2 plus 6. That's not a 6 at all. That's a... There. That'll do. Over -2 plus 2. Okay. And then this gives us 4 minus 10 plus 6 over 0, which basically this is 10 minus 10, which gives us our 0 over 0. So this is what I was talking about on the last page. So when we get 0 over 0, we need to reduce even further. So x squared plus 5x plus 6, this can be reduced to x plus 2 times x plus 3. So that's what that can be reduced to, and then over x plus 2. Boom. Okay, so what you would want to do here is, since we reduced it like this, we can actually cancel these two out, like that. And so now we're just left with x plus 3. So now we would end up writing the... I'll erase this when I'm done so we can have room for the other problems. So the limit of x plus 3 as x approaches -2 is equal to -2 plus 3, which gives us our 1. Or, yeah, there we go. So that's how you would solve that guy. It's not a very good box. I apologize. There we go. That's a bit better. Okay. So this x, like, reducing, this is something you're just going to have to know how to do, but this should be a familiar concept through pre-calculus and algebra 2, so hopefully it's not too hard for you guys. I don't think it is, though. Okay. So let me get rid of all of this real quick. Sorry, you can probably hear my keyboard, but I'm just going to erase it all by Control-Zing. I mean, I probably could have just used the erase tool, but it's whatever. Okay. Maybe I'll do it for the next one. Okay, so this one is different. So this is the same problem, but we are putting it in terms of +1. I guess this is a -1 down here for our 0 over 0. Okay, so first we're going to start again. I don't mean to write x. 1 squared plus 5 times 1 plus 6 over 1 minus 1 is equal to 1 plus 5 plus 6, because 1 squared is just 1, over 0, which is 12 over 0. Now, I mentioned earlier that 0 over 0 is something we have to examine further, but when we have like an actual number like 12 or something like 8 or whatever over 0, this is something we can't continue with. This is something that like doesn't work. So this doesn't work. So we would just consider this right here, this problem, we would consider this D, N, E. We would consider that D and E. So then I'm going to do this, get rid of that, and then I will just erase the... Let me change the... There, this is probably a lot easier than having to hear my loud keyboard. Okay. So that's that one. Okay, for our final example here, we have the limit of f of x as x approaches 2 is equal to x squared minus 4 over x plus 2. So then we have 2 squared minus 4 over 2 plus 2, which is 2 squared is 4, so 0 over 4. Now, 0 on the denominator is going to give us stuff that's that doesn't exist or undefined, but 0 in the numerator, I don't know if I said numerator first, it's denominator, my bad. But 0 in the numerator, that is just going to give us 0. So this one is going to equal 0. So that's what that one would equal. Okay, so now with this done, let us move on to the final practice problems for 2A. Okay, so we have the limit of f of x, just our equation. I forgot to write f of x here, but the limit of f of x as x approaches e is equal to ln x cubed. So e, or just Euler's number, we are going to plug that in here. So ln times e cubed. This is something you're going to need to know, but ln is natural log. This is something you should know from pre-calculus, so not a big surprise that it's here. But natural log and e, these guys just cancel each other out, and then this 3, I should probably write that a bit better. This 3 will just fall in place, so then this just becomes 3. Well, I guess ln e is like, it just becomes 1, but I kind of just consider it because it's whatever it is. So I guess I'll write the 1 here for you guys. But ln and e cancel each other out. They just make 1. So then the 3 falls down and you just get 3. So that's how you do that guy. Okay. So this next one is the limit of f of x as x approaches pi over 2 is equal to cosine x over cotangent x. So this one, cotangent, is cosine over sine, for those who don't know, but again, you should know if you're familiar with your unit circle and trig identities. But okay, let's get this guy in. So cosine pi over 2 over cotangent pi over 2. That's going to give us 0 over 0, because cotangent of pi over 2 is 0, and so is cosine pi over 2. So we're going to have to rewrite this guy, which is, it's going to look a little funky, but we're going to have to rewrite it. Okay, so cosine of x over, we don't really like cotangent because it's a little bit awkward, so like I said earlier, cotangent is cosine over pi, so we're going to do cosine x, that's not an s, cosine x over sine of x, like that, which is going to give us cosine of x times sine of x over cosine of x. Okay. So now that we have that, we can cancel these cosines because they're being multiplied and they just cancel. So then now we have sine of pi over 2, which is just equal to 1. So that is how you would solve this guy. Okay. So now that we did that one, let me erase all this stuff that I have here. If you want, you can just rewind the video or pause it to get how I did it, but I'm going to make room. Okay, so this one, we have the limit of f of x as x approaches 0 is equal to e to the 2x minus 1 over e minus 1. So this problem looks a little weird, but it's not that bad, I promise you. So e to the 2 times 0 minus 1 over e to the 0 minus 1. Okay, 2 times 0 is 0, obviously, and e to the 0, this is an identity you're going to have to know. E to the 0 is equivalent to 1. So that is something you're going to have to know for this class. This is a pretty important thing you're going to need to know. So since e to the 0 is 1, 1 minus 1 is 0, and then e to the 0 is 1 again, so 1 minus 1 is 0. So we have our 0 over 0 again, so we're going to need to rewrite and whatnot. Okay, so let me make some room, and then we are going to rewrite it. So we're going to have e to the x plus 1 times e to the x, sorry, it's not a good e to the x minus 1, and then we're going to have that over e to the x minus 1. The goal with rewriting is you want it to be the same as the denominator to try and cancel it out. So since we have e to the x minus 1 on the top and the bottom, we can cancel that like that. So then now we are just left with e to the x plus 1. Plug in the zeros. E to the 0 plus 1 is equal to 1 plus 1, which gives us 2. Just like that. Okay, cool. With those out of the way, we will move on to 2b. So this is 2b. This is also evaluating limits analytically, but this one is a little bit different. So we talked about evaluating limits when we have an equation, and so now we're going to talk about different methods we can do: conjugates, the common denominator, and the all-important trig limit. So this is kind of just expanding on what I did. Do I still have some weird thing? I don't know what that was. That was weird. Okay. So our learning targets here are going to be evaluate a limit using the rationalizing technique of conjugates, the common denominators, and trigonometry identities, like I just said. So let us get into it. So the first rationalization technique is simplifying using the conjugate method. So if there is a sum or difference of two terms in the numerator, then multiply the numerator and the denominator by the conjugate term. So what I mean by that is, so we have the limit of f of x as x approaches 0, and this is our equation. So the square root of x plus 1 minus 1 is over x. So again, we have to show the 0 over 0 step before we get started, so let me plug it in real quick. So square root of 0 plus 1 minus 1 over 0. 0 plus 1 is 1. Square root of 1 is 1. So we get our 0 over 0. On tests and whatnot, your teachers or your instructors, they're going to be looking for this step specifically. So make sure that you show it. It's very important that you show it. Okay. So this is what we do to get started. We're going to take what we have here, this equation right here, and then we're going to times it. X plus 1. Let me rewrite it because that equal sign is kind of in the way. So we're going to times it by the conjugate. So the conjugate of this would be, that's not a very good square root sign, x plus 1, and instead of minus 1, it is going to be plus 1 over the same thing. So x plus 1 plus 1. So now that we have this, as this square root right here would times by this will just cancel it out. So just know that, and it's it's pretty easy when you learn that, when you know that. Okay, so x plus 1 minus 1, because this minus 1 and times this plus 1 is just a minus 1 over, not a very good, okay, x times square root of x plus 1 minus 1. That's how we, or plus 1, not my bad. Because that's it didn't change on the bottom. Okay, so then we're going to plug in our 0. Or, not yet, my bad. We can cancel, and these cancel, so these 1s cancel, so then we just have x over x times square root of x plus 1 plus 1. So these x's can actually just cancel, like that. So then, now we are just left with a 1 on the top. 1 over square root of... It's not a very good... There we go. X plus 1 plus 1. So this is what we're left with, and then now we're just going to plug it in. So 1 over square root of 0 plus 1 plus 1, which is equal to 1/2. So that is going to be how we do this problem. So the big step here is just remembering that you need to times this right here, this guy, you need to times it by the conjugate. So again, since this was x squared, or square root of x plus 1 minus 1, we times the numerator by itself, but change the minus 1 into the plus 1, and then times the denominator by the same thing. From there, we are able to just simplify a little bit by removing these 1s because they canceled each other out, and then cancel the x's, and then we plug it in to get our real answer out of this. So that's the first rationalization technique. So then, now we move on to our another practice one for this concept. So again, right here, this is the limit of f of x as x approaches 4, and then this is our problem: 6 minus the square root of x plus 32 over x minus 4. So, like the last one, we actually have to show the step of us finding and solving for 0 over 0. So, let us get started with that real quick. 6 minus the square root of x, or no, my bad, I plugged in 4. 4 plus 32 over 4 minus 4. And then 4 plus 32 is 36. Square root of 36 is 6. So that's 0 over 0. So there we have our step there for it. Cool. Now we get into the fun. So, again, for this problem, like the last one, we have to times this by the conjugate. So in this case, since this is 6 minus square root of x plus 32, we would do this times 6 plus the square root of x plus 32 over 6 plus square root of x plus 32. Okay. So what this gets us here, this will be 36, because 6 times 6 is 36. And then these two will cancel, but since this minus sign is here, times this positive x plus 32, square root of x plus 32, this will be minus, and then in brackets we'll write x plus 32 over x plus 4 times 6 plus square root x plus 32. Cool. Okay. So now our next step is going to be to start simplifying a little bit. So to do that, we are going to first distribute this minus sign in here. Sorry, I'm clearing my throat a little bit. Okay. So now we have 36 minus x minus 32. 32, or 36 minus 32 is just positive 4. So then we just have over, I'm not going to write this denominator, but I'm just going to point an arrow here. So then now we are given 4 minus x over x minus 4 over 6 plus square root of x plus 32. That is very scuffed. 32. Okay. Okay. So since you see that the x is negative and that the 4 is positive here, we can do a little bit of fun, as I like to call it, and we can take out a -1, and then that would just give us x minus 4. So it just switches the sign, or not x minus 1, my bad, x minus 4. So this just switches the signs, and then gives us our x minus 4 that's present on the bottom. So then we have x minus 4 times 6 plus square root of x plus 32. So then that is not a bracket. Okay. Boom, boom, those cancel. Now we have -1, because that negative sign is still there, over our denominator, which is 6 plus square root of x plus 32. So now we're just going to plug in our 4 into the original problem, or from the base of the problem. 6 plus square root of 4 plus 32, which is just -1 over 12. And then our final answer is -1/12. Again, sorry my handwriting towards the end here is not super readable, but I think you get the gist of this. So I'll rewrite this 6 a little bit there. But you get the gist of it. This is how we would do this kind of problem. It's pretty tedious, but once you get the hang of it, it's not too bad. Okay, so now it is time for our next rationalizing technique. This is simplifying by finding a common denominator, then using the rules of fractions to simplify. So, as you can see here, we have the limit of f of x as x approaches 0, and we have this as our equation, 1 over x plus 4 minus 1/4 over x. So first, again, we have to start with the 0 over 0 step, so we're going to plug it in. 0 plus 4. It's not a good 4. Again, I apologize for my poor handwriting on this video. Over 4 over 0, which is just 1 over 4 minus 1/4 over 0, which is just 0 over 0. Okay, now that we got that, we can actually move on with the bulk of this problem. Okay, so in order to actually subtract these two properly, we have to times this each other's denominators on each fraction. So for example, we have to get these to subtract properly, we have to have x plus 4 and x plus 4, because whatever you do to the bottom, you have to do to the top. That's how you multiply, or that's how you subtract or add fractions. They have to have the exact same denominator to subtract. And then, since this does not equal the same thing on this side, you have to times this side times 4, and then times this side by 4. Okay, so now that you do that, we are going to have... sorry, stretching. We're going to have 4 minus x plus 4 over 4 times x plus 4, because this is 4 right here, and then this is minus x plus 4 at the top, and then this is just combining these two under one fraction. So this is this whole thing right here. This is this top right here, and then this is just all over x. Okay, so what do we do from here? Because this looks like a little bit of a mess, but we can distribute this minus sign at the top, so this will give us 4 minus x minus 4. These 4's cancel, so then now we have negative x over 4 x plus 4 all over x. So then now, since this is, we have like a triple kind of fraction thing right here, we have to format this correctly. So we're going to times this fraction, negative x over x, or 4 times x plus 4, negative x over 4, rewrite that denominator, 4 x plus 4 times 1 over x. Okay, so then now that we have this, we can cancel these x's and keep the minus sign. So then now we're going to have negative 1 over 4 times x plus 4. And then now we can finally plug in our value of 0. Correct? Yes. Okay. So now we're going to do negative 1 over 4 times 0 plus 4, which is going to just be negative 1 over 16. Right there. Boom. That is how we would do this problem. Right there. And then time for the next slide. So this is our third part of our rationalization. Just for the sake of time, I'm not going to do any extra problems with it. And I have to move on just because this is already a pretty long video as it is. But right here, this is our special trig limit. So sine of x, or the limit of f of x as x approaches 0 of sine of x over x is equal to 1. So this is important. You're going to need to know this, as this is something that you can just, when you see it, you can just automatically plug it in. So an example of us going to use this would be with this problem. The limit of f of x as x approaches 0 is equal to cosine x times tangent of x over x. So first, like always, we have to start with the 0 over 0 stuff and plug in the 0. So cosine of 0 times tangent of 0 over 0. Cosine of 0 is 1, and then tangent of 0 is 0, so you're going to have 1 times 0, which is just 0 over 0. So boom, that is the start of the equation. That tells us we have to move further into this. So remember that tangent is just sine of x over cosine of x, so since we know that and we don't want to deal with tangent, we can actually simplify this just a little bit. So then now we're going to do the limit as x approaches 0 of cosine of x times sine of x over cosine of x. It's not a very good S. Cosine of x all over our x. And then these cosines will cancel. So now we have sine of x over x is, and then this, like I said up here, this is our special trig limit, so this is going to equal 1. It's important that you know this because you would not get 1 normally if you just plugged in 0. So it's important that you know this because that is what the answer for this would be. Okay, so this is the final problem I'm going to do, but the rationalization rules, these also apply to the reduction method that I mentioned earlier at the start of this video. So our example here is going to be the limit of f of x as x approaches 4, and this is our equation, the square root of x minus 2 over x minus 4. Okay, so to start, we have to do the 0 over 0 step like always. So we're going to do square root of 4 minus 2 over 4 minus 4. Square root of 4 is just 2, minus 2 is 0, and then 4 minus 4 is just 0. So there. We have our 0 over 0 step done. Okay, so now we need to take this guy that we have right here and times it by the conjugate, like I mentioned earlier. So this is what this is how we would apply it to this one. Okay, so square root of x minus 2 over x minus 4 times square root of x plus 2 over square root of x plus 2. And then we're going to just get these canceled. So this is just going to be x minus 4, because 2 times 2 is 4, but this minus 2 makes it a negative 4. And then this just becomes x minus 4 times square root of x minus, or plus 2. Okay, so obviously since we have an x minus 4 on the top and the bottom, we can cancel these. So then now we have 1 over the square root of x plus 2. Now we plug in our 4, so 1 over square root of 4 plus 2, which the square root of 4 is 2, like I said earlier, and now we just get 1 over 4. Okay, well, that is going to do it for this lesson. I hope this was helpful for you in your journey into AP Calculus. Thank you for watching the whole way. I hope, again, you enjoyed this, and let me know how I can improve in the comment section below. I appreciate you guys staying all the way if you did, and I will see you later.